memories that come at night. Take me to an early time, back to a happier day, when I call you mine. And we sure had a good time when we started way back when. Bedroom talks and morning walks, oh how I loved you then. Summer skies and lullabies, nights we couldn't say goodbye, and of all of the things we knew, not a dream survived.
All right.
Good
Thank
afternoon.
you, John. That's very nice. Very nice. Always inspiring. You know, it's cool weather here in Texas, and it's very nice. And we're excited. The crew is here today to discuss the week progress. Lots of stuff going on, and we have a great guest. And I guess Llewelyn just had a little outage, but he'll be back in a second. There he is. So anyway, John Butler, how are you, sir?
I'm doing just fine. We had a lot of rain, as you know, in Austin, Texas. My electricity went off for about 8 seconds. I was a little worried, but everything is good. We have cool weather now. It's 30 degrees in Chicago, and it looks like winter is trying to get in here. All
right. Llewelyn, how are you today?
Very well, thank you. Very well. We have delightful weather up here in New England. Not like California, and I noticed that John just said that he had lost electricity for a little bit there. Maybe this is retaliation by the electric company for the rude things he said about the grid and its antiquity.
Well, I just want to know, did you say New England or East Texas?
England, sir.
Yeah, I don't know why he calls it New England, but it is East Texas.
Well, it was settled, you know, when Texas was part of Mexico.
I do understand that.
All right, let me say hello to our distinguished.
Just before everything worth having was invented in Boston.
It is.
Let me say hello to our distinguished guest, Dr. John Schemmel. John, how are you today?
I'm doing good, sir. I hear some rain in the background, so I'm. What would I be if I'm in San Antonio? If we're talking about New England, am I in the Caribbean then, or something like that? That's where I'm at.
You're in West Texas.
You're in West Texas.
Well, it's raining in West Texas then.
Excellent. Yeah, a little thunderstorming. So Dr. John Schemmel is a superstar. We're lucky to have him today. He is a graduate of University of Wisconsin in Madison, where he calls himself a Badger, but then he went to Lehigh to get a master's, and then he went to North Carolina State to get a PhD. So he's really all over the map too. So we congratulate him for that, getting perspectives. And then he ran civil engineering at Valparaiso University for a while, and then eventually he went on to create a company that is really interesting. Maybe he'll tell us about it if we ask him. And then he ended up choosing to come here to build the concrete industry management program, and eventually settled to run the civil engineering program at Texas State. And he's doing a phenomenal job driving that, and he holds the Bruce and Gloria Ingram chair, and as professor, driving an incredible startup with 100+ students already enrolled, and on its way to the 500 goal, and so lots of stuff that we can get from him on where the program is going and the vision of the future of smart buildings and infrastructure. So, but before we get there, I want to let you all know that we're trending all over the place, and last week was an interesting week. COVID, gave us some new 5,000 death. So we're almost at 190, 188, 688 when I checked earlier this morning. You know, as you know, that number keeps creeping up little by little, unfortunately. The number, though, it is trending down slightly. And then in terms of all the cases, we're at 6.287 million, roughly 282,000 cases up, also slightly trending down from last week. As you know, we're on back to school. Back to school is on, and there's all kinds of mixed reviews on that. You know, we have maybe we can have Dr. Shem will tell us what's going on at Texas State, and Dr. Butler will give us an update on University of Texas in Austin. And then sports leagues are, you know, obviously back, mixed reviews on those as well. So it's kind of interesting to see how the recovery is happening. So get your feedbacks on that. Real quick, the stock market is 900 points down from last week. The Dow, the New York Stock Exchange Index is down 200 points. The NASDAQ is down 800 points. So, you know, however, this morning, you know, it's already, you know, climbing up again. So interesting data point, oil crude prices are down $6.74 from last week, which I think is insane. But, you know, how can the prices go down so much? Maybe nobody's moving, nobody's traveling. I mean, it's just incredible. It's hard to believe that nobody's traveling, nobody's moving. So, and then the gas price is 1 cent down from last week in the Greater Austin area at $1.64 per gallon, which is super cheap, crazy cheap. Good job report added in August, 1.4 million new jobs. So the unemployment, according to the experts, is down to 8.4% in August. So maybe unemployment will get down to 4% before election happens. Gentlemen, what's happening? John, tell me what's going on, John Butler.
Well, I think it's some interesting things happening. First of all, there's a sameness where, you know, human beings have the ability to adopt, and you get this image that people are adopting to what's going on now, and that people are getting accustomed to doing what we're doing. They're getting accustomed to having food takeout. The virus numbers are interesting. What's more interesting now in the news is not the virus itself, but the signal and the noise. That is the whole idea of when did we know about, or when did the president really know about the virus? And I think that it has taken on almost a Watergate kind of characteristic. So we'll see how that plays out. Evidently, there was a new book that was done that talked about the signal and noise. That is, what's being signaled and when did we know? So I think that there's a sameness to the virus, and interjected in the virus is the political stuff. And we cannot allow the political stuff to get in the way of the scientific stuff, because we have to figure this thing out. University of Texas at Austin, let me talk some about that. I think that, you know, we switched almost overnight. Both my classes are online and going extremely well. I was just very, very interested to see how fast the university switched. And I do see a pattern as I look at my data. I think the juniors and seniors would like to be online, and the freshmen and sophomores like to go to school. So I think I see that pattern in my what I see. And the other thing is the jobs. I would like to know, Andreas, what the new job report is that number reflected of the new business models and the new jobs that's being created, or are people hiring people back? That's an interesting kind of question. Of course, the stock market, nobody knows where to put the money now. It will continue to do well. So overall, I think we're still in trouble, but there's a sameness to it. I think we're adapting to it very, very interestingly. I think that the industries like hotel and travel and the gig economy, I think they will be hurting for a very, very long time. So I think that's what's happening in my little world.
Got it. Llewelyn, what's your take?
Well, I think that you're painting quite an optimistic picture, and I think we're in, as I've said, week after week, we're in grave trouble. The unemployment figures are not accurate. They do not reflect the total loss of jobs that is going to haunt us this fall. we're slouching towards a constitutional crisis of unbelievable proportions, probably the greatest one since 1860, where we have the high possibility that there will not be an agreement on who wins the next election and which votes counted in the next election. That's a very grave prospect. The stock market, I think, is sustained, as Johnny has said very correctly, week after week, more by an abundance of money looking for a home than it is by any reflection of the economic activity in the country. You cannot have as many people out of work. Forget about what the official figures show. It's calculated to be somewhere over, somewhere north, maybe as much as 30, but somewhere north of 20 million people. You have restaurants and small businesses and retailers that have gone out of business for all time, and their supply chains are going out of business. My own informal way of counting this, by talking to people and calling them up, is that we are in a bad situation, likely to deteriorate before it gets better. Now, all of this will begin to change if there is an effective vaccine available by the end of the year. Anthony Fauci says he thinks it's possible by the end of the year. The president says before the election. There seems to be a lot of doubt. I've been talking to the pharmaceutical companies. They do not think they will have it by the election, or those I've talked to, 3 of them. So my feeling is that the situation is quite grave, quite perilous. There's a lot of happy talk going on, and we're going to rue it.
Got it. Dr. Schemmel, how do you see it?
I'm a little concerned if at least 3 of the 4 people here, because I haven't heard from you, Andreas, agree. And that's not normally the case, right? Put 4 people in a room and have 4 different opinions. But listening to the others, you know, I'll speak from just personal experience. It just in terms of people becoming accustomed to things. I went out this morning, had to go to the store, which I try not to do. I fall into that category of high risk. So I've been basically inside my house for the better part of, what is it, 6 months now or something since March. But people at the store were wearing masks. Actually, someone tried to walk in and they forgot their mask, and several people yelled at them to go back and get their masks. But I mean, so I think people are settling in. I think I would agree with that. I agree too with the comment about the vaccine. I know I'm not, at least from my family's perspective, they're not going to let me out of the house for anything formal until there's a vaccine that actually has been proven effective. And so I think to talk about a vaccine is probably premature. I have family that is in the medical field. And so I think that there will be one, but to say that there's going to be one by November, I don't think that's going to be the case. And I'm not sure how much into the new year, because I've heard comments about, you know, into the middle part, first quarter, maybe second quarter of the new year. So I would concur with your friends here on their commentary.
Okay. Well, you know, it's really a hodgepodge, right? But I can tell you that, you know, clearly there's activity going on. We have an outline over the last, 10 weeks that there are losers and winners here. COVID has accelerated digitalization needs, and a lot of companies are jumping on it and taking advantage of it and growing like crazy and pulling the economy towards them. And then there's a bunch of people that are, in a quagmire, probably, on their way to the bottom of the sea. They don't know what's going to happen. Hopefully there'll be a lot of lifelines send out there. But when you look at what's going on in terms of transformation in the industry, you can see a significant amount of growth. Again, we are traditionally talking week-to-week changes. So on 5G, which is probably the biggest trend we will live in our lifetime here in the next 20 years. Telefonica just started offering 5G services in Spain. You probably know that China is the leading country with 5G subscriptions with north of 20 million subscribers. South Korea just flipped over 8 million 5G subscribers. And I'm happy to report that Apple announced their annual announcement of new products in September, which is on the 15th at 10 a.m. Pacific time. They will be announcing the new 5G iPhone, which is expected to be a blowout, out of this world, crazy, I want to, I'll take 3 product success. And it's going to be a barometer of what happens with 5G in the United States. According to all the carriers, they are, they have, if not nationwide coverage, somewhat almost nationwide coverage. So again, it's just fascinating. And then the last thing that I would say on 5G, and take your take on that again, and we keep hammering that, but Telefonica Germany just decided to build a private 5G core for all industries, separate from the commercial network in Germany, so that the car companies and the manufacturing companies and all that can actually manage using 5G for their own purposes, their own campuses, their own infrastructure, sort of in a virtual network, if you will, developed by the carrier, but not competing with the commercial network where people are tweeting and emailing each other and exchanging photos. And that's a radical transformation. And more importantly, they're doing this in partnership with Amazon. Amazon AWS is being used as the backbone of all the information for this private new carrier network in the entire country of Germany. So we have talked a lot about the fact that 5G is really not about you and I tweeting each other. We don't need 5G for that. 5G is really going to enable the fact that we're going to have 100 billion things talking to each other, machine to machine, talking to each other at the speed of light, controlling trains and power grids and buildings and everything. And so it is happening. It is coming at us at the speed of light. A lot of us don't see it, but it's happening. Gentlemen, what do you think? John Butler?
I think let's look at some trends. I'm going to put on different kinds of hats. First of all, I'm going to put my statistical demographic hat on. Go back to my graduate days at Northwestern, which is just south of, a little bit colder than that little Wisconsin school. But let me just put my hat on here. I think that there are some trends that might affect 5G. And that trend is away from the city in terms of density. I would think that the business model of 5G would depend upon the density of the population. I would think that if you then if you say that, you have to ask this question. If it is true that in New York City, the major metropolitan areas, they want to now become like Texans, Llewelyn. They want to live in houses with yards, and they want to be able to step out, rather than living on top of each other and stepping out and looking at a tree and thinking that the tree itself comes out of concrete. So seriously, I do see some trends that might affect the business model of 5G. Andreas, I might be wrong, but I think that the business model would depend upon the density of the population, but the trend is not to go away from density. The other thing that I see with 5G is that the competition, as you know, with China is absolutely off the scale. Mm-hmm. And of course, 5G in China is fed by a government. They have a market economy sitting on top of a communist government, but they get all of the resources that they need. And I see a coming, let me put my presidential hat on when I had a presidential appointment back in the day. So I put on my Washington hat, and I do see a coming conflict with the business model with America and China with 5G right in the middle because of the ability to look at anything, to see anything, and et cetera. So I think that as we talk about 5G, and I've been reading about the trends and looking at all of the demographics, sociological trends, what people are looking forward to in the future, then I look at the absolute monster, the greatness of 5G, which is just really, really, China's done a great job. But I think that we're going to have to really appreciate 5G, but I think those kind of trends will have an impact on the business model. Andres, I'm especially interested in your idea and in your concept of, my concept that density will negatively affect the business model of 5G, since the model is for people to move away from dense places to more places that are scattered out. And then they're back to 2G and 3G. You know, when I go to West Texas or New England, and then I'm in 3G.
Right.
I was just looking at walking around Newport with somebody who's in the telecommunications business, who was pointing out all the 5G installations on poles. Ideas about West Texas are a little bit out, but don't worry about it. I think 5G is going to be a very important part of the digital future, but I don't think it's going to be as immediately revolutionary. I think it's going to be fairly slow to come to fruition, to its full impact, as is, for example, 3D printing, additive manufacturing, which is taking a huge role, but you don't see it. I went out to a factory in San Diego where they make compressors and parts and things, and they were printing all sorts of things. You don't hear about it, but it's changing manufacturing. It's changing military logistics. I think it's going to be a quiet revolution. There isn't going to be a bomb go off or a gun fired, and 5G is here, and human happiness is increased by a factor of 10. It's not going to be like that at all. And it's going to depend, this new digital future, going back to something that Johnny and I both believe in, and that is the electric utilities have to do something about resilience. We cannot go on not having reliable electric supply. Every time there's a storm, the electricity goes off. The possibility of a cyber attack, particularly not so much on the IT side of the house, but on the OT side, it's large and possibly growing. And the utilities have to get up to speed. They have to rethink the future of the utility. I think it's disaggregation. I think it should be in a situation where it can break itself into small pieces as a defensive mechanism. John Wellinghoff, when we had him on this broadcast, said something, the former chairman of FERC, something very similar, that the utilities have to meet 5G, have to meet additive manufacturing. They can't have the intermittent supply we get at the moment with the uncertain future of electric supply. The utilities have been, I think, unduly optimistic about their ability to meet the needs. They've talked resiliency, but have they proved it? Not with the hurricanes, not with the fires. Show me the resilience.
Yeah. Dr. Schemmel, maybe a couple of comments on how you see it, but more importantly, what's Texas State doing? What's the engineer of the future look like? What is the civil engineer that you are cooking right now? You have already a second semester on board. Where are we heading?
You read my mind, sir. Because I was gonna ask you, do you have our little infographic handy that while I make a few comments, can you find it on your computer? I think you got it somewhere.
Absolutely.
The one thing I was going to say and can comment on while you do that is civil engineers need to figure out what 5G is. You know, when you're talking about 1G and whatnot, I don't know, we may still be in the 500 megahertz world functioning right now. And that's a very unfortunate thing because there's a lot of potential, and not just in 5G, okay, there you go, but in technology in general and its application to civil infrastructure. And it's a challenge right now just to get some of this stuff going. So, you know, I mean, 5G is going to be really significant and important to us being able to do this. And Andreas, you talked about millions of things talking to each other. Imagine every piece of infrastructure, every mile of interstate, every bridge talking to the other bridges and to the vehicles as they're driving down the interstate. And so civil engineers have got to get after this far more than they are right now. And what Andreas has brought up is actually our little infographic on what we're doing at Texas State to educate the civil engineer of the future. And so our classic civil engineering education is that gold circle that says infrastructure asset, where we teach people how to design, analyze and design various pieces of infrastructure, water towers, you know, the easy things to see, buildings and bridges, but underground storage facilities and subway systems and those things as well. So we all do that. I mean, that's civil engineering across the country, across the world. But where things are headed is the application of technology, and things like 5G are a part of that. So students of the future have got to understand how to detect events that occur with infrastructure assets and what happens to the data. How does it move from place to place? And how do we analyze it, and the tools that are used, and how do we know if the information is valid? And then what do we do with that data to maintain these pieces of infrastructure? Because I say to my students, every time you drive down 35 and there's a repair going on, that's because the structure is come to the end of its life and actually well past it. And now we've got to figure out how to make things last even longer. And one of the ways to do that is to monitor the structure and do little incremental repairs along the way and have things last for a greater period of time before you have to come in and do such major overhauling of any kind of an asset. So whether it's 5G or 6G, technology has got to become a bigger part of our infrastructure. We hope that we're on the cutting edge of doing that for our students. And educating them in a different way than's happening on the other campuses across the country.
Excellent, excellent. And I think that you know, the focus clearly is accelerating everywhere. So as we see what's happening in things like smart cities, you know, again, Rogers in Canada has deployed 5G across 50 new cities just in the last 2 weeks. T-Mobile just added another 81 cities in the US. China Mobile in Hong Kong just did a deal with a company called SkyDrone, which is going to be a business-to-business delivery system in Hong Kong. So you can, in the supply chain, instead of relying on trucks in Hong Kong downtown, if you've ever been to Hong Kong, it's a super busy place. They're moving to SkyDrone type delivery infrastructure capabilities. So you'll be able to move, hard goods that usually go on a truck on drones flying around the city. And this is all enabled because it's 5G. You know, you need 5G delivers the bandwidth and the latency and the real-time controls to have the right network capabilities to do such a thing. So it's just fascinating what's happening. And clearly, you know, we're in a hiccup moment here with all that delivery. But let me pause for a second and take a quick moment to remind us about our success with Digital 360 Summit and where we're heading from now here on. So, you know, you all probably remember vividly, it seems like it was years ago, but it was actually just a week ago or so, August 18th, 19th, and 20th, and 25th, 26th, 27th, we had, you know, actually almost 80 speakers and 60 keynotes, 11 panels. Dr. John Schemmel moderated the panel on smart buildings and infrastructure. And I thought that panel was a phenomenal panel that really dig deep into all the details. But we had, you know, all kinds of panels and obviously Dr. Butler and Llewelyn King were in the Smart Cities panel, and they did a phenomenal job as well. So we're very thankful for you three participating. And here's a snapshot again of the companies that spoke and participated on the podiums, if you will, virtually with Zoom. And so we're grateful to all of them. And then just want to remind everybody and announce that the 2021 edition is going to be May 18th, 19th, and 20th, which is the week after the spring semester ends. And it's going to be live, and we're predicting we're going to have it in San Marcos at the Embassy Suites. And so we're looking forward to that. And we want to thank Texas State University for being the sponsor of the Digital Roundtable. So let me circle back and maybe ask John, Dr. Schimmel.
I have a question to ask John Schimmel when there's a chance.
Yeah. So if you, I was going to ask questions for Dr. Schimmel. So if you guys have any questions, go ahead, chime in. Go ahead, Llewelyn.
I'd like to, first of all, I think that your sensors on every bridge and road are highly practical, but I feel the data you're going to hear is these installations talking to each other, and what they're going to be saying is more funding, more funding. So beware of that. Then I think.
So in other words, nothing will change. It will be as it is today.
Well, no, there is something else happening. Sea level rise. This is going to require enormous amount of civil engineering. If we're going to put up berms and barricades, if we're going to put walls around Manhattan, maybe around Texas, I don't know. Texas, their problem is particularly unusual. The demands on the civil engineering component of our society are going to increase. And I think we need to know whether they can be met or whether we should have alternative planning. Also, civil engineering in many, many ways is still steel and concrete in many, many ways. Are we going to get beyond steel and concrete? We've got beyond copper wire for telephones. We've got beyond a lot of things with new materials, new approaches, including the printing of houses. Are we going to see these new technologies and new approaches, and particularly new materials, maybe carbon fibers, maybe even going even smaller with chlorine and things like that? What's this future? It cannot really be a straight extrapolation of what we have today. There won't be enough concrete and cement and steel to encase the nation from the seas.
So first I've got to thank you for saying concrete and cement, because that's something that most people do not realize that there's a difference between them. So I always appreciate when somebody recognizes that, and so thank you. But you are correct. This is one of the things I think where technology is going to, if civil engineers can figure out how to use it and different ways to apply it, it's going to change things. Because how do we figure out what's going on with the structure right now? We are building a lab, and Andreas is probably have talked about the infrastructure research lab and things that are going on at Star Park and the CIEDAR initiative at Texas State. But we build a facility to test components of infrastructure to try to figure out how they're behaving. But we don't really have the full picture, because we can't get inside the concrete beam or column. We're just seeing things on the periphery, and we're measuring large scale behaviors, and we're not able to see things internally. And we have to figure that out and figure out how other materials can be used to be put in place of steel and concrete. And one of the best ways that's going to happen is that we can actually use sensors to monitor the performance and the behavior, and do that out in the field, not just in the lab. And that's where things just aren't happening right now. That's why I say, civil engineering, and in some respects, engineering needs to figure out what 5G is and what it can do. And we need people, we actually need electrical engineers to come and sit next to me. And we need manufacturing people to come and sit next to me. and talk to each other and say, I need to be able to do this with this, pipe. How can you help me figure out how to do that in, electrical guy, and how do we make that sensor manufacturing guy? And those conversations just don't take place enough. Somebody's going to figure that out, and is going to realize that there's money to be made, and they'll go with it. But right now, it's very slow. John,
I was speaking to my colleague, my scientist in Canada, day before yesterday, and we were talking about green, and they're taking carbon right off the smokestack and putting it in concrete.
Yeah, that's a big thing now.
As a way to really try to understand the relationship between concrete and green. And they had a business plan competition, and they took the best 4 ideas and funded them to a tune of $50 million to come up with that solution. So I think that if you look at the trends, as my in-laws in Cleveland, Ohio would say, we don't understand why there's no potholes in the Roman streets that are 6,000 years old, and there are potholes all over Cleveland today. I think that concrete will always be here, but I still haven't heard my answer, Andreas, about the business model of 5G as it comes aboard. But my question is, are we experimenting in America with carbon and concrete, and looking at how carbon might strengthen concrete, how we can look inside of concrete, and this is what I heard that was going on in Canada, and I'll leave it right there. And I still want Andreas to address the business model of 5G.
You're muted, sir. Andreas, you're muted.
You're muted.
So I didn't know if you wanted to go first or me go
first. No. I'm gonna defer to you first, but remember to maybe highlight some of the things that Dr. Awayo and others are doing, and we are exploring with materials and things, and you guys are driving a bunch of stuff, so you may want to talk about some of that.
Well, I want to, it's interesting. The world and life is interesting because things happen, and it's some other part of your world, and then this conversation comes up. So to just tell you about how some things are slow in civil engineering. I was actually studying the use of carbon fibers in 1993 for the federal government, for the Corps of Engineers. So we were looking at carbon fiber pre-stressing strands, so a form of reinforcement in bridges that would be for magnetically levitated train systems. So 1993, we were investigating this, and here we are today. How many bridges are you aware of that have carbon fiber reinforcing in them? You don't hear, you don't hear anything about it, right? So it's slow going, but you're correct. There's that. Another thing in terms of green that is happening is people are looking at capturing CO2 coming out of cement plants and trying to find ways to actually bring that back into the manufacturing process, because basically a cement plant is one of the most regulated facilities outside of a nuclear power plant, but it's one of the most regulated manufacturing processes that is around, and you talk about something with a lot of sensors. And so there is a lot of stuff in terms of green in a variety of ways. So one way we are looking at basically environmentally friendly or green concretes is what are the things that you put into that concrete. But part of it also is how do we make it last longer? So green isn't just about what you put in it, but if it stays as it is and it doesn't deteriorate and it doesn't have to be repaired and it doesn't have to be replaced so often, that's also green. Because if something lasts 50 years instead of 10 years, now I haven't replaced it 5 times.
Right.
And so one of the things that's happening at Texas State, as Andreas had mentioned, is Dr. Fred Aguayo is looking at how do we make concrete last longer with what we have in it. So you can make the materials green, and so the structure will be more environmentally friendly, but you can also extend its life. And that's a big part of what we're trying to do at Texas State with our technology focus.
I have a question, if I may, and that is, there seems to be a poor relationship between steel and concrete. Bridges fail as often as not because the steel is corroded, whereas concrete can be very long-lived, as the Romans built the Colosseum out of concrete. As soon as they learned to use better sands, the Egyptians invented it, the Romans perfected it, and we seem to have unperfected it because our bridges don't last very long, and even our roads, as Johnny said so correctly.
Well, this is the reason that that is true, because it is true, is it really goes back to business. We are trying to find out how to be at the edge of the performance of the structure and the cost. And so the reason we have potholes in Cleveland is because we're trying to use the least amount of the most expensive components, the most of the least expensive components, and take it to the edge. And when you do that, you are going to have failures. You know, you're not going to be perfect all the time. And you're talking about a material in concrete that plus or minus 20%, you know what I mean? Because the manufacturing process may be well controlled for cement, but every rock that's in there is different. Every particle of sand that's in there is different. Every batch of what is supposed to be the exact same concrete is different. So when you take the material to the edge in terms of its performance and its cost, and then you have this variability in the material as it comes out of a plant and is placed by humans that aren't going to do it in the exact same way every time. They're going to have failures. So it's not that we don't understand it or can't do a good job. We could make a concrete pavement that would have no potholes, that would go through a Cleveland winter or a Green Bay winter or a Minneapolis winter, many of them, and not have potholes. But in today's day and age, that's going to be 2, 3, 4 times the cost of the road as it is. So imagine if we could do a better job of monitoring that roadway, and when some portion of it was getting close to the limit, that we stepped in and made a small repair in that place, and one that was of quality, because pothole repair, you guys all know, if anybody that drives in the north knows, pothole repair is not a great, you know, highly specialized skill and talent. You know, I mean, so they come back. You fill up the hole and it comes back. But imagine if we could monitor that structure, that pavement, and make repairs well in these small increments. You wouldn't even be talking about the repairs, and you'd be talking about a pavement that would last a long time, because we could put more money in at the front end to a better quality material, or use a different material. And so this is where I see things have to really happen in civil engineering, is we've got to figure out how to really watch our infrastructure and watch it properly and watch it well, and then figure out how to maintain it.
So a couple comments on that. As Dr. Schemmel was talking about the vision of sensors everywhere in the infrastructures, components talking to each other, a sidewalk to the car, to the pavement, to the building across the street, to the street light, to the traffic light, and all these things that are inanimate objects now having a pulse, you know, a heartbeat. You know, sharing data, information. They're all calculators. They're counting how many times they're stepped on, how many times, you know, in all that data. I mean, what a tsunami of richness of data, Dr. Butler. I mean, what would one do with, yeah, I mean, buildings consume 60% of the energy in the world, period. Well, if they were instrumented, they would create at least 40% of all the data in the planet, which is not created. It's absent today, right? I mean, what would the world of social physics look like with that much data?
Well, you know, I think that, and of course, this is my research area, and I think that we will be in need of what we call scientists that look at data. You know, we used to call them statisticians, but everybody run from statistics. Now we call them data scientists, or we call it data analytics, but it's just regression toward the mean. But I think also, as we've talked about here, and Llewelyn has talked about the bad side of this, is that the number of jobs and how the disciplines will really, really merge. Okay, so there's absolutely no reason at all why the statisticians cannot get together with the engineering and really look at what we call social physics. And that is, John, the ability, and this is what I do, to write the equations for the movement of people. So if you look at marketing, if you look at sociology now, it's not about asking people, what do you think? So when I see a building now, I see a data set. When I see a facial recognition, I see a data set. So John, right now, I scrape all of my data off of LinkedIn. I scrape my data off of Twitter. And right now, as you know, everything that we tweet is now going to the Library of Congress. So if we're still around in 100 years, people can do the data analysis on what America looked like. So you're exactly right. And I like that concept where every building is now alive. Every building now has a heartbeat. But what it means mathematically for the economics side, and we've got to put the business model on it. It means that every building, every city will have to have a lot of data scientists, because data in and data out, as we know from the old days, is just garbage. So we're going to have theorists to write the equation. We're going to be like finance. We have as much data as finance that allow us to make decisions in the future. And the other thing is, that's more important here that John kind of really talked about, was that we'll be able to see when a structure is about to decline.
Yep.
We don't have to wait anymore to say, maybe there's a bridge will break. There was a bridge in Pennsylvania that they declared as horrible, and they couldn't tear it down. It was built so well. So once we get the census, all of the census in, the visioning the economic rewards is just blazing. And then when everything is hooked up, everything is really, really talking to each other. And we are a data-driven society. So I think the whole society changes. I think the reporting changes. I think it goes to shoes. I think Nike will have a shoe with a sensor on it that tells you when it goes bad, and et cetera. So we now are in the realm of the data scientists.
Right. So one thing I'll mention to you that I thought was very interesting. We early on in the development of our academic program went around to other programs on campus to talk to them. How can we work with you? How can you work with us with this vision? And we went to math because we needed them to do a couple things for us in terms of modifying the math classes that they currently offer. And I started to tell one of the faculty there about this vision that is now CIEDAR, and we'd have this lab, and out there would be all of these disciplines. And I said, including math, you should be out there, as you're saying, John, and basically from the data scientist perspective, you should be out there standing next to me. I said, if we don't have someone like you standing next to me for every project ongoing out there, we have failed. And he looked at me and he goes, no one's ever invited me to see anything like that before. To him, this was just unbelievable that a civil engineer or an engineer or somebody in the science, the engineering science would come to the mathematician and say, come and see what it is that we're actually doing so that you understand the equation and how to help us to act, monitor and evaluate what's going on here. They were hugely excited, and because this is just, it's not happening, and so I agree with you. When some of these connections begin to occur, and as you were mentioning earlier, become the normal, normal behaviors, that's going to make a huge difference for us.
Yeah. Let me make a second point on the 5G business model. So here is a sort of my humble synopsis of what's happening. So 5G is being equated to the platform, to the capability, to the technology, to the must-have, to the water to make the pie, to this ingredient that would enable Industry 4.0. In Industry 4.0, birth in Germany, is basically the reinvention of manufacturing and supply chain and all kinds of things. And the power went out again here. San Marcos doesn't have a good power company. Need to come down.
So your power really went out.
Yeah, that's okay. This is the beauty of batteries. This is why you want self-sustained systems, so you can, life doesn't stop, right? So, so the point is, John, that in the old days, telecom networks were directly related in their investment to people use and density. But people use and density does not collocate, or the Venn diagram is not a perfectly matched to where the assets are of everything that is created, rails and for the trains, and power lines for the power, and water, distribution systems, and dikes and dams. And there's a lot of infrastructure that needs this connectivity to do the things that John is talking about, Dr. Schemmel. And so the business model is going to change, because instead of 5 or 6 carriers buying frequency and owning the monopoly of that distribution network, the 5G is going to be offered on licensed spectrum, and it's being offered on unlicensed spectrum, and it's being offered to a small manufacturing company. It is being offered to a multinational company globally. And so there will be the creation of thousands of networks managed by specific companies with their own partnerships with new carriers, new third-party carriers, new players that are traditionally what's called mechanical and electrical procurement companies, sort of the companies like AECOM and Black & Veatch and Burns & McDonnell's and Bechtel, and these companies are going to be building thousands of networks dedicated to industry across the globe. And because the assets, again, utility assets, primarily water, gas, and power, and then the railroads really are everywhere, right? And when you think about the civil engineering partnership on building the infrastructure for those businesses to run every day, as Dr. Schemmel would know better than anybody, they're pervasive. They're pervasive everywhere. And so it is the fact that civil engineering, needing sensors to manage infrastructure, needs the presence of those networks everywhere that infrastructure is, that will make 5G happen. And so the cost, basically the answer to the business model is that the cost of building a 5G network is 10 times cheaper than buying a 4G network, just for me to build a tower for you and I to talk. So compare apples to apples in terms of the old device versus the new device, and what is the cost. And so, what we're going to see is an explosion of 5G services across the agriculture, across all the fields, across covering all the infrastructures nationwide in a very short period of time.
That really helped. And 6G will be ushered in by the new computing, by what I call the scientific computing. It's all scientific, but really the advanced computing with 6G, because we're not talking 6G, but it's certainly right around the corner now.
Oh yeah. And again, I remind you that the throughput and the importance of 5G is that 5G is taking everybody that has a 5G phone will go and have 1 gigabit, 1,000 megabits per second of broadband from wherever that phone is, right? Today, at best, in a phone, you get 20 megabits. From 20, you're gonna go to 1,000, like that. The same phone, right? And that is gonna take you to 7 billion phones and 100 billion things. And all of a sudden, this network is everywhere, right?
But this is what's interesting to me. So the civil engineers are physically designing and building this network, but they're not using it.
Right.
So they're right there working with, the owners to build the network, to physically build the network. and they're not saying, oh, by the way, tap them on the shoulder. How do we take advantage of this thing?
Well,
You know?
this is again, it's a journey. It doesn't happen overnight, but the genie's out of the bottle. Remember that Google owns a company called Sidewalk Labs, which is a company that makes smart buildings. So very few people have connected those dots, that Google is actually chasing this, because if buildings are going to deliver that kind of data, Google is in the data business, right?
It's just very interesting that's happening, and you know, I can just see. But what's the implications for Llewelyn? I asked Llewelyn this. What's the implication for the people side of 5G? What's the implication for jobs and the interaction between people? John Llewelyn has really been on top of looking at all of this and its impact on people and cities themselves and how they change and can have negative impacts on what we do. I've been more on a positive side. He's been more on the negative side of what's happening here.
Well,
Llewelyn, you want to elaborate on your thoughts on?
Yes, well, thank you, John. It's not even a thesis, but my feelings are that ever since the Industrial Revolution, each time we've had a new invention that has produced more products, made more work, and of course we have a huge global employment industry as a consequence. People have jobs by and large, but we now have inventions which for the first time since the new common engine may subtract jobs. And I wonder what is going to happen to those people who are not capable of working in the knowledge world. And these are the people who are losing their jobs now.
They need to go back to school.
And no, because some people are not able to absorb the mere idea that you can put millions of people through school and they will come out able to compete with Johnny is just, I mean, there are people who are subject to, they may be able to compete with you, Andre, but not with Johnny.
Well, but can I comment on that? Or are you still?
The open issue is what will they all do? What will the population bomb that's building in Africa, for example, what will it do? It's trying to get into Europe, and if they could, they would try to get here. Likewise, Eastern Europe, where there's underemployment, much of Asia, where there's underemployment. But that's not a solution. We are not, at the moment, it is not in sight where the new employment is going to come from. Historically, it has always arrived.
Yeah. Dr. Schemmel?
Well,
the one thing
history where it's not going to arrive.
I would say two things. One is we're like in the civil engineering world, we're talking about needing new technology, physical devices that don't exist today. So there'd be, there are companies to be built from that perspective of developing and supplying that. But the other thing I would say from an academic perspective, when you said, no, some people can't learn some of these things, and I understand where you're coming from, but I think we're finding new ways to educate and train people and to do it. I mean, if we do some of these things with VR and AR, they're going to be able to learn things that they didn't think that they could learn before, or they felt frustrated in the way that they were taught in the past. So I think that from an academic perspective, we can find ways to raise the level of understanding of individuals beyond where it is today, and get it in line with the kind of jobs that we are going to need people to be able to do. And I think, and I mean, I'm not an economist, so this is my comment about, I'm not a tax attorney and all that kind of stuff. Not an economist, and I don't know those details, but I see opportunities for developing new industries if you come to the vastness of infrastructure and look to develop sensors and technologies around sensors.
I hope you're right. I mean, I hope we can find ways of overcoming certain limits that we have on IQ. You can't turn somebody into Hans Bethe, if you will, a mathematical genius, by further educating them. You couldn't turn me into somebody who can balance his checkbook. I'm so innumerate. And I think that's something that we don't know. We don't know if this is a seminal moment in time when automation, which is what we're really talking about, when automation becomes a job subtractor and stops being a job adder. And it has not happened yet, and I hope it doesn't.
Yeah. On a closing note, last quick remarks to make on progress of digitalization transformations going on. Uber just pledged earlier today 0 emissions by 2040. So Uber will work with their owners of vehicles, if they don't control the vehicles, to find a way. So I imagine Uber will accelerate and do electrification of vehicles, financing of electrification of vehicles in their business model, so that they will, as a company, be 0 emissions by 2040. 2040 is like next week.
I think we'll make that. I don't think that's an unachievable goal. I think the speed at which electric vehicles are coming to market, this is very achievable. I don't think it's even very revolutionary in ambition. This is achievable. I think we will see Uber and many other things which will have electric vehicles, and a large part of the population will have electric vehicles.
Well, that would be music.
That is another huge change, and that too is a job subtractor. Because all those nice people at the service station who change your oil and do those things every 3,000 miles will be out of work. Electric cars don't need that kind of maintenance.
I very much appreciate that aspect, though. As an EV owner.
Yeah,
I have said that
John, remind me.
If there is one thing that we should make sure happens to eliminate, climate change and risk and all that, would be if we can shift a significant number of, gasoline cars to electric vehicles, that would eliminate all the problems of CO2 and what have you, right? So I think that, again, I see the writing on the wall on that everywhere. So I personally, I'll go down in history as the most optimist of all of us. And I see all kinds of great things happening and great changes happening. I see the unleashing of data. It's fantastic. It's phenomenal. And I go back to the fact that, I'm trying to figure out how to get my nonprofit to solve world hunger and homelessness by selling data, personal data from people into a marketplace. So data is the new oil, gentlemen, you know it. And we need to figure out how to make it happen and to create a new ecosystem with new companies, new business models, new tax laws, new everything.
Well, I hope there's a lot of demand for those golf carts that you guys are driving.
Golf cart.
That's it. Where can I plug this thing up? I said, go to Great Hills Country Club and plug it in with my golf cart.
All right, gentlemen, we are out of time, and I'm going to ask Dr. Butler to pull up the guitar and send us away with maybe something happy.
Can't wait to get back on the road again.
Nice.
I love is making music with my friends. And I can't wait to get on the road again. On the road again. Seeing places I have never been. Seeing things I may never see again. And I can't wait to get on the road again. We're on the road again. Like a band of gypsies, we go down the highway. We're the best of friends, insisting that the world keep turning our way and our way. We're on the road again. Just can't wait to get back on the road again. Love our life is making Tulsa with my friends. And I can't wait to get on the road again. And I can't wait to get on the road again.
Happy trails, happy trails.
Happy trails. Take care, everybody. Thank you, John.